We have this problem to solve. The first question is to sketch the graph of the function f of x equals x to the power of 2 plus 2 from 0 to 2. Question number B says to compute the integral explicitly of this function from 0 to 2, to find the area under the curve, and C, to use the trapezium rule to approximate the value of the integral from 0 to 2. Okay, let's do the first one. F of x equals x squared plus 2, and we want the values from 0 to 2. Okay, so for x equal to 0, f of 0 is gonna be 2. For x equals 1, f of 1 is going to be 3. And for x equals 2, f of 2 is going to be 6. So our graph is going to look like this. For x equals 0, the y value is 2. For x equals 1, the y value is 3. And for x equals 2, 6. So basically, it's going to be a parabola shifted 2 units up in the y direction. But we focus only on that part of the function, because the function, we define it, we want to find the integral from 0 to 2. So the area under the curve. So for B, we are looking to find what is the area under the curve. So we have to compute this integral. This is straightforward to compute. We split the integral into 2 integrals. That's x cubed over 3. And the integral of this function is 2x. So it's 1 over 3 times 2 to the power of 3 is 8. So it's going to be 8 over 3. And 0 to the power of 3 is 0, of course, so the other term is going to vanish. Plus, I have 2 times 2 minus 0, so it's going to be 2. So it's 8 over 3 plus 4. 8 over 3 plus 12 over 3 is going to be 20 over 3. And this can be written as a decimal. This is going to give me a decimal. So my integral is 20 over 3 and is the following decimal. If I compute it explicitly. Now for C, how do we work out the C1? So let's graph the function again. One, 2, 3, 4, 5, and 6. For x equals 0, so we have f of x equals x squared plus 2. For x equal to 0, we have this coordinate here. For x equals 1, the y value is 3. And for x equals 2, the y value is 6. Now what I need to do is the following. my A is going to be this point here, 0, my B is going to be 2, the two endpoints of the interval. And let's say I want to split it and the number of trapezia to be 4. So the step H is going to be B minus A over n, 2 minus 0 over 4, 0.5. So I have 0.5 here, 1.5 here. So I'm going to split it into 4 trapezia. 1, 1 more here, 1 more here, and 1 more here. I have A1, A2, A3, A4. So I have to calculate each area of the trapezia. So the A1 is going to be, what is the small base here? F of 0. Plus the big base is going to be f of 0.5 times h, which is 0.5 over 2. And the second trapezium is going to be f of 0.5 plus f of 1 times 0.5 divided by 2. A3 is going to be f of 1 plus f of 1.5 times 0.5 divided by 2. And A4 is going to be f of 1.5 plus f of 2 times 0.5 over 2. So the total area equals A1 plus A2 plus A3 plus A4. That's f of 0 plus f 0.5 times h over 2 plus f 0.5 plus f1 over 2 times h plus f of 1 plus f 1.5 times h over 2 plus f of 1.5 plus f of 2 times h over 2. I can take common factor the h over 2, and I have inside f of 0 plus f of 0.5 plus f of 0.5 plus f of 1 plus f of 1 plus f of 1.5 plus f of 1.5 plus f of 2, close brackets. That's h over 2 f of 0 plus 2 times f of 0.5 plus 2 times of f of 1 plus 2 times of f of 1.5 plus f of 2. So that's going to be 0.5 divided by 2 times f of 0 plus 2 f of 0.5 plus 2 f of 1 plus 2 of f of 1.5 plus f of 2. And I have to evaluate the values of the function at f of 0. I have to find what is f of 0, f of 0.5, f of 1, f of 1.5, and f of 2. So that's going to be 0 squared plus 2, 0.5 squared plus 2, 1 squared plus 2, 1.5 squared plus 2, and 2 squared plus 2. Once I calculate these values, I plug them inside here and it will give me the total area under the curve. Let's find what is f of 0, so it's gonna be 2. That's going to be 2. 0.5 squared plus 2 is going to be 2.25. That is going to be 3. Then we have 1.5 to the power of 2. 1.5 to the power of 2 plus 2. Is 4.25, and then you have this value 6, so it's going to be 0.25. f of 0 is 2 plus 2 times f of 0.5, 2.25, plus 2 times f of 1, which is 3, plus 2 times f of 1.5, which is 4.25, plus f of 2, which is 6. So we have 2 plus 2 times 2.25 plus 2 times 3 plus 2 times 4.25 plus 6. This is 27 times 0.25. That's 6.75. Which is close to the value that we have calculated before. Of course, there is some error there with the trapezium because you are overestimating, but you see how it works here.